This is one of a series of 6 general revision videos for Maths GCSE at Foundation Tier. These are based on the Pixie Maths revision mats, which are available at the link below for free. So I'm going to work through these area and perimeter problems first. Calculate the area and perimeter of the following shapes. So area of a rectangle is just length times width, 5 times 8, giving me 40 centimeters squared. Always put the correct units in. Perimeter, it's all the sides added together, so I need to remember that there are those to include. 8 plus 8 is 16, 5 plus 5 is 10, so 16 plus 10 for the perimeter is 26 centimeters. Not squared, just a straight line added together, 26 centimeters. Question 2, area of a triangle is half times base times height, which means I can ignore anything that isn't a base or a height. I'll ignore the 5 and just do half times 3 times 4, or half times 4 times 3 is easier because then I can half that 4. That's 2 times 3, which is 6 centimeters squared. Half times 4 times 3 is the same as half times 3 times 4, by the way. Okay, perimeter for that one, I just need to add them all together. So 5 plus 4 plus 3. Which is 12 centimeters. Area of this one, I need to split it into 2 different rectangles to calculate the area. I'm just going to choose to split it this way. You could split it that way as well instead, but I'm going to choose to split it vertically here and label my extra sides. This part of the rectangle is 2 times 7, so that's 14 centimeters squared there. And this is 2 times 4, so that is 8 centimeters squared. Add them together, the area is 22 centimeters squared. For the perimeter, I need to make sure I've labelled all the sides before I begin, every single side. So this one is missing, height of 4 centimeters there and 2 centimeters taken off it. This must be 2 centimeters left there. I've got that side, I need to label that side, which is 7 and 2 together, making 9 centimeters. And now that I've got all of those, I can calculate the perimeter as 9 plus 4 plus 2 plus 2 plus 7 plus another 2. So that is 18 and 2 fours, which is 26 centimeters. Calculate the area of the following shapes. Here is a parallelogram. A parallelogram, we need to do this, we're just asked for the area in this case, not the perimeter. For a parallelogram, you need to think of a rectangle. It is just base times height, like a rectangle, but we just need to make sure that that height is perpendicular to the base. It's the height rather than the side length. So ignore that, it's irrelevant. Base times height is 7 times 4 is 28 centimeters squared. And this one, a bit more complicated, it's a trapezium. We need to find the average of the top and bottom sides, which we do with the formula. This is on the formula sheet. Half of a plus b, where a and b are the parallel sides 6 and 10, times by the perpendicular height, which is 4. 6 plus 10 is 16, half of that is 8, so I've got 8 times 4, which is 32 centimeters squared. Just to be clear what we're doing there, we're finding the distance that is halfway between a side of 6 centimeters and 10 centimeters, because that would be here, an 8 centimeter line, halfway between them. And if I were to cut that corner off and stick it in there, and cut that corner off and stick it in there, I would end up with a rectangle that is 8 centimeters wide and 4 centimeters tall, which is what I've done here. So that's where the area of a trapezium gets worked out. Okay, next one, circles. Area and circumference of the following shapes. So area we know is pi r squared, where r is the radius. So in this case I'd be doing pi times pi 6 squared, and remember to square the 6 before you multiply by pi, because indices come first. So that is 36, lots of pi. If your answer is asked for in terms of pi, that's how you'd leave it. But on a calculator, 36 times by 3.142 gives me 113.097, etc. Normally round that to 3 significant figures, which is 113 centimeters squared. Circumference is either 2 times pi r, that's a 2r in there, which is the same as pi times the diameter, which is twice the length of the radius. So in this case I'm given the radius, so I'm going to do 2 times pi times 6. 2 times 6 is 12, so that's 12 pi. And on a calculator, times by 3.142 or times by pi gives you 37.699, which I'm going to round to 3 significant figures, 37.7 centimeters. That's circumference. Next one, very similar. I'm doing pi r squared, but of course I need to work out the radius first. That is pi times 4.5 squared, half of the diameter. 4.5 squared. So 4.5 squared on the calculator gives me 20.25. So 20.25 times by pi. And my answer to that is 63.617, which I round to 3 significant figures as 63.6 centimeters squared. Circumference, this time I'm going to use pi times diameter, pi d. C equals pi times 9, so that's 9 pi. On a calculator that is 28.274, which is 28.3 centimeters to 3 significant figures. Next step, calculate the missing angles in each of these diagrams and give reasons for your answers. So I need to justify what I'm doing each time. This one I can see I've got 90 degrees. I don't need to give a reason for that, it's labelled. But in order to find A, I'm going to add 90 plus 105 gives me 195. I know that angles at a point add to 360 degrees. 360 minus the 195 gives me 165 degrees. So A equals 165. My reason is angles at a point add to 360 degrees. At a point, add to 360 degrees. If you're asked for a reason, you need to write out the reason in full. It won't happen that many times in your exam, but when it does, you need to write out the reason properly. In this one, I'm going to do 180. It's an isosceles triangle, which means that I know that this is the same as that. So I need to use the rule that angles in a triangle add to 180 degrees. So my first step is 180 minus 34 equals 146. The reason for that is angles in a triangle add to 180 degrees. In a triangle, then my next step is to take that 146, which is those two combined, and divide by 2. That gives me 73 degrees, because base angles in an isosceles triangle are equal. And that's my 2 reasons given. And the answer is there, of course, B equals 73 degrees. Question 3, the diagram shows a regular pentagon and I've been asked to find one of the interior angles of that pentagon. So Easiest way to do this is to find this angle here. I do that with 360 divided by 5, because there are 5 angles. 360 divided by 5 is 72 degrees. And the reason for that is exterior angles of a polygon always add to 360. Add to 360 degrees. So that gives me 72 degrees here. And C is 180 minus that 72 degrees, which is 108 degrees. And my reason for that step, I'll just write it down here, is that angles on a straight line add to 180 degrees. So you could also, instead of using that approach, we've got our answer now, C equals 108. The other approach you could use is that the total interior angles add to n minus 2 times 180, where n is the number of sides. So you could have done n minus 2 times 180, that is 3 times 180, which is 540, and then divided that number by 5 to get each interior angle. 540 divided by 5 is 108. So that was another method you could use. You'd have to justify that with sum of interior angles equals n minus 2 times 180, and then you'd have to show that dividing by 5 because there are 5 angles. So you'd have to write that out in full. I think my method is quicker with the exterior angle, but it's good to know both options. Question 4, D equals 81 degrees. We can see that these are angles on parallel lines. These are the 2 parallel lines. And where that line crosses them, we can see that this junction could be lifted up and put exactly onto that junction of the lines. So anything that's in the same place are corresponding angles. So D equals 81 degrees because corresponding angles on parallel lines are equal. Now, I know also in this that E could be called a supplementary angle to 81 because they're in the same U-shaped bit of the parallel lines. But seeing as I've just worked out that D equals 81, for E I can say that E equals 180 minus 81, and therefore that's 99 degrees. My reasoning being that angles on a straight line add to 180 degrees. And finally, F is 81 because it is vertically opposite that one. So F equals 81 degrees because vertically opposite angles are equal. Vertically opposite is just what we call them. Whenever they are either side, like opposite sides of a junction, we call those vertically opposite angles. This is also vertically opposite to that angle, so anything across that junction of 2 lines. Okay, final section of this is surface area. Oh no, there are 2 more. Surface area and volume. So, calculating the volume of a cuboid, which we've got here, like a stretched cube, a 3D rectangle, is the easy one. We do length times width times height. So it's literally just multiplying the 3 things together. So volume equals 2 times 4 times 7. That is 8 times 7, which is 56 centimeters cubed because it's volume, and we had centimeters times centimeters times centimeters, making centimeter cubed. Surface area is more complicated. I need to think about the net of the shape. So here's my cuboid net. I've got 2 sides which are So if I think about the base, that is 2 by 7, so that's 14, and there's another 14 on top. Then I've got this front bit, which is 7 by 4, so that's 28, and another 28. And then I've got these end bits, which are 2 by 4, they are 8, and another 8. So my total surface area is 2 times 14, 2 times 28, and 2 times 8. And adding them all together, that is 28 plus 2 lots of 28 is 56, plus 16, giving me a total area of 100 centimeters squared. So another way to think about that with a cuboid is just to make sure that you've done each of the pairs. I've got 7 times 4 times 2, 7 times 2 times 2, and 2 times 4 times 2. And that's what's gone into the 100 centimeters squared there. Volume of a cylinder is like any prism, base times height, where base is, well, what I mean by base is the cross-sectional area, the area that's repeated all the way through. In this case it is pi r squared for the base because it's a circle, times by the height. R is here 4, so we've got pi times 4 squared times by 10. 4 squared is 16, times by 10 is 160, so that's 160 pi in terms of pi, and then if I put that into my calculator, that is 160 times 3.142, which is 502.65, which I would round to 503 centimeters cubed to 3 significant figures. Surface area of a cylinder is a bit more complicated. I need to think about the net again. So at the top of my net is the circle, and it's also got a base. And then if I rolled out the side area, the curved surface area, I would end up with a rectangle. And that rectangle has a height of 10, as we see here, but the length of this side of the rectangle is the same as the circumference of the circle, because it would wrap around the circumference of the circle. So for this I need the area of the base here, so that's pi r squared times by 2, because I've got a base and a top, so that is pi times 4 squared times by 2. So that is 32 pi for the base and the top. 16 times 2 is 32. And then this bit I need to do pi d for the circumference, which is pi times 8 pi. And then I need to multiply that by 10. So curved surface area equals 8 pi times 10, that's 80 pi. So the whole area is the base and the top, 32 pi, plus the curved surface area, 80 pi. I'm going to run out of space here, I'm going to need to go into this bit. That is 112 pi, which I put into my calculator and get 351.85. So that's 352 to 3 significant figures, and that is centimeters squared because it's an area, surface area. Okay, final section of this is measures. So I've got 350 milliliters to liters. I know that there's 1,000 milliliters in a liter, that's what the milli means. So I've got less than 1,000 here. So less than 1,000 is going to be 0 point something. And if I had the 1 in that column, then these would be next to that column, 0.35 liters. This one confuses people, 6,300 centimeters squared to meter squared. Well, I know that there are 100 centimeters in a meter, so if I think about that square that's 100 centimeters by 100 centimeters, that doesn't mean that there are 100 centimeters squared in a meter squared. It means that there are 100 times 100 centimeters squared in a meter squared. So 100 times 100 gives me 10,000 centimeters squared in a meter squared. So if I need to convert this, I don't have 10,000 here. I've got one less than in the column next to it, 6,300. So that is going to be 0.63 meters squared. I take that 6,300 and I divide it by that scale factor of 10,000. And that gives me my answer of 0.63. The other way to think about that is divide by the scale factor that we normally use, set 100 centimeters in a meter, and do it twice because it's area, so there are 2 dimensions involved. Same thing, 6,300 divided by 100 divided by 100 again gives you the conversion factor and gives you the answer 0.63 meters squared. Question 3. Mia drove a distance of 343 kilometers. She took 3 hours and 30 minutes. Work out her average speed, giving your answer in kilometers per hour. So kilometers per hour reminds us that is distance is kilometers over hours is time measurement. Speed equals distance over time. So her speed equals 343 kilometers distance over the time, but the time we've got to be careful about. We do want kilometers per hour, so we want to keep the units as hours. However, 30 minutes is not 0.3, it's 0.5 of an hour. So we want to take that 343 and divide it by 3.5, 3.5 hours. That gives us 98 kilometers per hour. So always watch out for time with that. Question 4. Daniel leaves his house at 7 o'clock. He drives 87 miles to work. He drives at an average speed of 36 miles per hour. At what time does Daniel arrive at work? So again, we're going to have to be careful with time at the end of this. If speed equals distance over time, and here we have been given a distance, 87 miles, and we've been given a speed, and I need to find the time from that. I need to switch places with these. So time equals distance over speed. You might know that from your triangle as well. Speed is distance over time, therefore time is distance over speed. So I need to do distance 87 miles, speed of 36 miles per hour. 87 divided by 36 is 2.416 recurring. That tells me it's 2 hours. As a fraction, 2.416 is 29 over 12, which is 24. So 12 goes into 29 twice with a remainder of 5. 2 and 5 twelfths. So 2 and 5 twelfths. 5 twelfths of an hour. If I think of 1 12th of an hour as 5 minutes, if you think of the clock face, every 12th of an hour, because there are 12 parts of the clock face, every 12th of an hour is 5 minutes, or 60 divided by 12 is 5. So 5 times 5 is 25 minutes. 2 hours 25 minutes is how long it takes to get to work. Add that to 0700, and that is 0925. 2 hours and 25 minutes later. Quite complicated, that one. Finally, the mass of 5 meters cubed of copper is 44,800 kilograms. Work out the density of copper. Now, density is mass per volume, mass divided by volume. Again, need to memorize that formula. Density is mass divided by volume, so we get density equals a mass of 5. No, it's not. The volume is 5. Sorry, the mass is 44,800 divided by the volume, obviously, in meters cubes. So that gives me 8,960 kilograms per meter cubed. Just check the units, kilograms divided by meters cubed. And that's the density of that. Okay, that's the end of the space, shape and measure worksheet.